Now we're going to practice this theorem, right? The theorem is if I find my feasible region, my solution set, the optimal solution exists and is one of my corner points. So I need to find my corner points, and then what you do is you plug them into whatever objective it is you're looking for. And so right now we're just going to practice this. We're not going to practice setting it up with an application until the next set of notes. All right, so right now we're just going to practice the theorem. And I'll probably do, since examples take a little while, I'll probably do one example at a time. Right, so the first example of practicing, which is example 2 in these notes. I suppose that we set up, all right, a maximum profit that we want. So P represents my profit. My profit equation is 5x plus 10y, and x and y would have some meaning. All right, they'd have to be some values. Subject to the constraints where I've got 3 inequalities. So I have to find a profit that lands in the system of constraints, the system of these. So I have to find x and y values. There's a whole lot going on here. I need an x and y value that makes all 3 of these inequalities true and will give me my maximum profit in this equation. And it's complex, but as it turns out, based on the previous theorem, it's not really that hard to do. I find my feasible region, I determine what my corner points are, and then my maximum value has to be one of those corner points. All right, and then we test to see what it is. That's where we use the table. All right, so graph the feasible region, locate and label the corner points, because that's what we need in order to optimize our value. And so you can do this on the calculator. I'm going to do it by hand. So I'm going to start with my first equation. I'm going to do my work kind of over here. So my first equation is x plus 4y equals 12. I like to use my intercepts because a lot of times I need to find corner points. And a lot of times my intercepts are my corner points. So that's why I like to use them. So I'm going to find 0 for the x and 0 for y. Alright, so when x equals 0, I get 4y equals 12, and so y equals 3. And when y equals 0, that one's easy. That zeroes out and leaves me x equals 12. Alright, so there's the points I'm going to use for my first line. And then I'm also going to do my test so I know which side to shade on. Actually, I'm going to graph it, then I'll do my test. Alright, so go graph my line first. And again, try it again using a straight edge for these. And so, I've forgotten what my points are already. 0, 3, and 12, 0. Alright, so 0, 3 puts me here. And 12, 0 puts me there. Alright, so I wish I had a straight edge, but I don't. Ugh. Alright, so my line, again, hopefully you guys draw yours a little straighter. So this is my x plus 2y equals 12 line. And I am going to use 0, 0 as my testing point. Alright, so test using 0, 0 for this first inequality. So if I plug 0 in, I get 0 out, 0 greater than or equal to 12, that's false, and so that's the side I want to shade. So I'm going to shade towards the 0, 0, right? 0, 0 is here. And so I'm going to do my shading last because I think it gets messy if you start shading right away. So this arrow here is indicating I'm going to shade below my blue line. Alright, and I'm going to do that last. Alright, now my next line. So I'm going to do a very similar thing. So I'm going to erase this because this is kind of my scratch work off to the side. So hopefully you'll have it because I'm going to erase it and I'm going to do my next line here. So that was line 1. Now line 2, and I would encourage you to use different colors. So I'm going to use red. So my second line is negative x plus 2y equals 6. Same thing, I'm going to use my intercepts. So the first one is x equals 0. I get 2y equals 6, so y equals 3. And that one's y equals 0, negative x equals 6, so x equals negative 6. And then I'm going to test it after I graphed it. Alright, so 0, 3, so 0 actually hits So it's probably going to be a corner point, right? It's going through 2 of my lines. So it hits there at that same place, 0, 3, and then negative 6, 0. So over here. Alright, so there's my second line, which was negative x plus 2y equals 6. And I'm going to use, again, the same test point, 0, 0. So I'm going to test using 0, 0. This time I plug 0 in. 0 less than or equal to 6. So that's true, which means that's my true side. And so I want to shade on the other side of my red, right? 0, 0 in this case for the red line is true, and so I don't want to shade on that side. And so for the red line, I'm going to shade above it. So again, I'm going to do my shading last. You could shade now. This is just my personal way to do it. You have a better method that you prefer. Use your better method that you prefer. Alright, so I'm going to shade above my red line, and I'm going to do all my shading last. Alright, so I've got one more line left to graph, and I'm probably going to do green. So I've got to go get a green color. Alright, so line 3, x plus y equals 9, so 0. I'll do a slightly darker green. Alright, so this one's easy. If I plug 0 in, I get 9 out for both of those. So 0, 9, 9, 0. And then I'll test it after I graphed it. Alright, so 0, 9 puts me, sorry, 9, 0 puts me there. 0, 9 puts me there. Alright, so I'm going to try to graph this straight as I can. I can't seem to draw a straight line to save my life. Especially going that way, because I'm right-handed, so going in that direction is extraordinarily hard. So there's my wonky green line. So hopefully you guys have a straight edge and can do a little better. So again, I'm going to use 0, 0 to test again. So 0, 0, because it's just easy. Plug it in, so I get 0 less than or equal to 9. That's also true. So the 0, 0 is true. So the 0, 0 is on the true side, so I want to shade on the other side of the green one. So shade on that side of the green, right? Keep the true. And so now I'm going to do my shading. Alright, so I want to shade below my blue line. So everything below my blue line gets shaded. Above my red line, so everything above my red line is false. And to the right of the green line, so everything to the right of the green line. Alright, so all of those. And so I do get like a triangular shape. Alright, and so this is my feasible region. And these are my corner points. That's a corner point, that's a corner point, and that's a corner point. Which, if I graphed it nicely, and on this thing it's not necessarily the easiest to graph it, I should be able to determine what those are. So I'm going to call that first one A, this one B, this one C. And so now I go put it in my table. Alright, so that's the hard part. Once I've got it graphed and I've found my corner points, then it's just really just to see which one of those gives me my best value. Alright, so my A, B, and C. So A, B, and C. A is easy. A was the corner point that I used to graph, so I don't really need to check that. That was the point 0, 3, and I used 0, 3 to graph both the blue line and the red line. Alright, so it went through those. So I don't need to check that one. But B and C I have to check. Make sure they're true, because if I did a good job, I could tell what they are, but it's not necessarily, because it's, again, especially the way I graph mine, I may not have got them perfectly, and so you always need to check these. So either solve the solution, find the way they intersect, or test to make sure they're true. All right, my B looks like it's at the point 4, 1, 2, 3, 4, 5. And that's why we write down where they go through so that we'll check it. So I do need to check this one. So I need to check this one, and I need to check that one. A I didn't because I used it to graph. Alright, so B went through the red line, which was our x plus y equals 9. And that checks, right? If I take 4, add it to 5, I get 9. And then it went through the green line. The green line was our negative x plus 2y equals 6. And I should check that it works in that one as well. So if I plug in 4, I get a negative 4 plus 2 times 5, which will give me 10. Negative 4 plus 10 does come out 6, and it does check. Alright, so that is my corner point. And I'll do the same thing for C. Again, if I did a good job graphing, it should, just like I said, give me the right one, but you always double check. So 8, 1. Looks like on the graph it's at 8, 1. It goes through the blue line and the green line. So the blue line was x plus 2y equals 12. Check that it works. So if I plug in 8 plus 2 times 1, alright, that one doesn't check. I wrote it down wrong. That's why it doesn't check. It's like it should check. I wrote down 2y instead of 4y here. Always go back to the originals because it really is easy to do that. Make sure I wrote the rest of them down right. Negative x 2y plus 6. And x plus 4y. Alright, the rest of them I did fine. I put a 2y there instead of a 4y. And so that should have been a 4y. And that should have been a 4y. Then it should check. Right? I know 8, 1 is my point, so it should check. So check it. 8 plus 4 times 1. Now it equals 12, now that I've got the right equation there. And the other line it goes through is the green line. The green line, double check the green line, is my x plus y equals 9. And that one does check too. X plus y equals 9. 8 plus 1 equals 9. Alright, so they do check. So those are the right corner points. Just didn't have the right line written down initially. But you should always check it, because if you don't have the right corner points, you won't get the right answer, and you want to make sure you get the right answer. Alright, so these are the corner points, which means right now these are the possible optimum value. Will give me out my possible optimum values, right? Those are my possible optimum values. Right, now the check it is you take your coordinates and you plug them in here, right? These are all x and y's, where I can get my maximum in. And so you take your x and y's and plug them into this equation. One of them will give you out your maximum profit. One of them will give you out your minimum. And again, we want the maximum in this case. And so we'll find and see which one does that. Give me out my maximum. I don't know why my pen stopped working. There we go. Alright, so P equals 5 times 0 plus 10 times 3 comes out 30. So if we've got 0x and 3y, we get out $30 in profit, which I'm going to guess that's my smallest. I'm going to guess either the 4, 5, and the 8 one's going to give me my biggest. Alright, so 5 times 4 plus 10 times 5. That gives me 50 and 20. Okay. 20 and 50, which comes out 70. And then the last one, 5 times 8, 10 times 1, 40 and 10, so that's 60. 40 and 10, that's 50, not 60. Right. And so 70 is the biggest. Right, that's my optimum value. Alright, so my optimum solution, the solution is the maximum. So we get a maximum, if I can write it out, profit, whatever it is, we didn't tell you what the profit was, of $70 when the optimum value is when it happens, when x equals 4 and y equals 5. Right, that'll give me out my optimum value. I'm going to continue on because I'm actually using the same. So that's an example of a maximum, right? Maximum. So I'm using the same feasible region, the same set we had up here. You look at your notes, it's exactly the same. So the same solution set, the same feasible region. What I changed so that we could do a minimum case was I changed what we were looking at. So suppose the previous equation was on cost. We want to maximize cost. Well, suppose we know, maximize profit. We want to minimize cost. And so that's all I did. I just changed what we were looking for. But the only part of the problem this changes is my testing part. This is the same feasible region, same constraint, same solution set, same corner points. But the test is going to come out different because I'm looking for a different optimal function. But my max and mins are still going to be located at the same three places. Same three possible points, my A, my B, and my C. And I'm not going to write these. This is the same as before. The corner points for A was that 0, 3, 4, 5, and 8, 1. This time we want to find the minimum cost. And so these are our possible places where we can get a minimum. And what you do is, you take them in. And so the only new part is what we're looking for. So we're looking for minimum cost. And again, minimum typically is the case with the 0. Not always, but you need to test it. But minimum typically is that case. All right, so we're going to plug into this new objective. 5 times 0, 4 times 3, which comes out 12. 5 times 4 plus 4 times 5, which comes out 40. And 5 times 8, 4 times 1 comes out 44. And so this is my smallest. And so the optimal solution is we have a minimum of 12 when x equals 0 and y equals 3. And at that corner point is my minimum. We actually had a different maximum if we were looking for the maximum cost. We always get both. We always get the max and the min. It's just which one is the question looking for. We're always guaranteed both. We're guaranteed a max and we're guaranteed a min. It's just whichever one we're looking for. Typically cost, we want minimum. Typically profit, we want maximum. Alright, we will stop there. We'll pick up the next example in the next video.